The transportation revolution is set to redefine how vehicles, goods, and people move across cities and continents. By 2035, electric vehicles are projected to make up 70% of new car sales worldwide. This shift is supported by declining battery costs, advances in solid-state technology, and the expansion of charging networks. Solid-state batteries are expected to enter mass production by 2028, offering ranges beyond 500 miles per charge and improved safety. Major automakers are preparing to phase out internal combustion engines, and many governments are using incentives and stricter emissions standards to accelerate this transition. These changes are expected to significantly reduce transportation-related carbon emissions and reshape the automotive industry. In the logistics sector, autonomous trucks are on track to dominate long-haul freight by 2035. Current pilot programs in regions like the southwestern United States show that self-driving trucks can lower fuel consumption and operate with fewer interruptions. As the technology matures, these vehicles will be able to run nearly around the clock, reducing delivery times and labor costs. During the transition, human operators may supervise multiple vehicles remotely, ensuring safety and reliability as fleets shift toward full autonomy. Urban transportation will also see major changes. By 2040, urban air mobility networks using electric vertical takeoff and landing, eVTOL, aircraft could carry 10% of city commuters. Early routes will likely connect airports to city centers, cutting travel times and easing congestion. Companies are already testing certified eVTOL designs, and cities are planning for vertiports on rooftops and repurposed helipads. Safety requirements will include redundant propulsion and autonomous flight controls, enabling reliable operations even in emergencies. High-speed ground transport is advancing as well. Vacuum tube systems, sometimes called transonic vacuum tubes, may enable ground travel at speeds up to 1,000 kilometers per hour by 2045. Prototypes are being developed that use magnetic levitation and low-pressure environments to minimize friction and energy use. Countries like China are testing reduced-scale systems, and underground routes are under consideration for connecting major city clusters. Technical challenges remain, especially regarding tube maintenance and emergency procedures, but the potential for rapid intercity travel is drawing significant investment. Aviation will undergo a significant transformation through the adoption of hydrogen-powered aircraft. By 2035, regional flights using hydrogen propulsion are expected to be commercially viable. Aircraft manufacturers and startups are already conducting test flights with hydrogen electric and modified turbofan engines. Hydrogen's energy density makes it a practical solution for routes under 1,000 miles, and new infrastructure for hydrogen production and refueling will be needed at smaller airports. Suborbital cargo delivery could become feasible by 2040, allowing high-value shipments to reach any point on the planet in under an hour. Early applications will likely focus on urgent medical supplies and critical components, with companies exploring reusable launch platforms for rapid point-to-point transport. While costs and insurance remain barriers, advances in reusable rocketry and payload integration are pushing this technology closer to reality. Smart infrastructure is expected to play a key role in supporting these new modes of transport. Roads equipped with wireless charging will keep electric vehicles powered while in motion, reducing range anxiety and supporting autonomous fleets. Vehicle-to-grid integration will allow electric vehicles to help balance electricity demand, and dedicated lanes for autonomous freight convoys could further improve efficiency. Real-time data from road sensors will enhance traffic management and safety. Micromobility options, such as e-bikes and scooters, are projected to account for half of all urban trips under 5 kilometers by 2030. Cities are expanding bike lanes and regulating shared mobility services, while next-generation vehicles offer rapid battery swaps and improved safety features. These options provide flexible, low-emission alternatives for short journeys, helping to reduce congestion and emissions in dense urban areas. The cumulative effect of these innovations is expected to have the transportation sector's carbon emissions by 2050 Continued investment in sustainable fuels, high-speed rail, and infrastructure adaptation will be necessary to overcome challenges related to resource supply and equitable access. As transportation networks evolve, the resulting shifts in mobility patterns and infrastructure will intersect with broader social and economic changes, setting the stage for new dynamics on the global stage.